Okay, question 43 again is find the inverse matrix. Remember, checking the matrix exists when the matrix is a square matrix 2 by 2. That's okay, and it's non-singular. So we compute the first to determine associated with this matrix. Okay, it's multiplication this and this plus, and multiplication this and this minus. This is 0 and -1 and +1, double negative plus 1. The answer is 1, different to 0. The matrix is non-singular, and the matrix exists. The inverse matrix exists. Now, in this case 2 by 2, so I propose using the cofactor formula. So a cofactor is equal, for example, the first cofactor is, okay, let me copy again our matrix 4 times. And remember the signs for each cofactor. Okay, this is plus, this is minus, this is minus, and this is plus. So the first cofactor is this, is 0. The second cofactor is this, is -1, but actually it's +1 because negative, negative, negative. Now the third cofactor is this, is 1, is -1. And the last cofactor is this, is +10. Okay, now transpose. Transpose means change the row for column. So this row is 0, 1, I become like 1 column 0, 1. And this row is -1, 10, I become like 1 column -1, 10. And when you divide by determinant, the determinant is 1, directly division by 1, this is the inverse matrix. Inverse matrix is 0, -1, 1 and 10. Okay, let's do the verification. At least multiply 1 time in 1 over. It doesn't matter. I propose that you completed the idea. Inverse matrix times A is 0, -1, 1, 10 times multiplication. The original is 10, 1, -1, 0. Okay. Row number 1 times column number 1. 0 times 10 is 0, and -1 and -1, +1. Row number 1 and column 2 is 0 times 1, and this is 0. Everything is 0. And second row and first column is 1 times 10 is +10, 10 times -10 is 0 again. And the last is multiplication 2, and there's a row 2 and column 2 is 1 times 1 is 1, and 10 times 0 is 0, is 1 is identity matrix again of the dimension 2, identity 2. Okay, those I left for homework. Okay, you prove que A times A inverse must be identity matrix also 1, 1, 0, 0, identity dimension 2. The answer of this is inverse, que es the option B in our handout. Okay, question 44 and 45 I want to solve it using the calculator. It's 2 matrix 3 by 3. And compute the inverse matrix using the calculator. Let's see. All clear. Suppose let me go to editor matrix editor. Matrix A is 3 by 3, and the number is 1, 0, 0, negative 1, 1, 0, 1, 1, and 1. Okay, let's go to the home screen, checking the numbers, see everything is okay or no. Super. Now find the inverse. This is the answer. The answer is the matrix, square matrix again. 1, 1, negative 2. 1, 1, negative 2. 0, 1, negative 1. 0, 1, negative 1. And 0, 0, 1. 0, 0, 1. Okay, now to make sure this is perfect, this is inverse matrix. 3 by 3 again. I do the multiplication. I store this matrix in B and multiply A times B and B times A. A times B as identity matrix of the dimension 3 and B times A. Again, as identity matrix of the dimension 3. Perfect. Confirmation. Now let's go to the second example, 45. Again, second matrix editor, matrix A, 3 by 3, and this is 1, 1, 1, 2, 1, 1, 2, 2, and 3. Okay, let's go to the home screen. Let's check in the matrix A. Okay, perfect. Now let's compute the inverse matrix. The inverse matrix is negative 1, 4, negative 2, negative 1, 4, negative 2, 1, negative 1, 0, 1, negative 1, 0, and 0, negative 1, 1. 0, negative 1, 1. And this is our inverse matrix, 3 by 3. Now let's do the multiplication to make sure that the inverse is correct. So now store in the matrix B and multiplication A times B. Identity matrix of the dimension 3 and B times A. B times A. Same answer. Perfect.